Hello everyone. In this video, we'll be looking into one of the very simple method to calculate the project duration and the critical path by the method of splitting the network into different paths. So this method you can adopt into a small network diagrams. Now we will look into the various steps that we should follow in order to determine the critical path of the project and also calculate the total duration. The first step is to draw the network diagram for the given activity and predecessor relationship. We usually go with AOA network diagram, that is the activity on arrow network diagrams. Once the network diagram has been drawn, we are then going to identify the various paths of project completion. The paths should be a continuous one and it has to always start with the first event and the path should end with the last event. Keep in mind that it should be a continuous path. Once the path have been identified, we have to then draw all the paths horizontally along with the activity name and its corresponding duration. Then we are going to calculate the time consumed by each of these paths that we have identified and drawn by adding the duration of all the activities which are there in that particular path. The path which consumes the maximum time is the total duration of the project, and that path is called as the critical path of the project. We have to keep in mind that there will be at least one critical path in a given project, and it is not restricted to only one. We can have multiple number of critical paths in a given project. Also, we should keep in mind that the critical path need not connect all the activities in the project, since, as mentioned above, it is the path which consumes the maximum time by joining the events from the first till the last. Into an example in order to understand how this process goes on. Now we will draw an activity on arrow network diagram. So we'll look into the table given. So we have 7 activities A to G, and we have the first activity which is activity A. So before we start with the network diagram, we are going to draw an event followed by the first activity. Once the activity is completed, we are going to close the event. So once the event has been closed, now we have to go for the next activities. We have to see the predecessor for those activities. So we can clearly see that activity B, C and D, all 3 of these have activity A as the predecessor. So that indicate activity B, C and D are concurrent. So we are going to draw these 3 activities B, C and D. Now we will write down the durations of each of these activities, which are 6, 4 and 2 respectively. So once the activities have been drawn, we have to close those activities by an event. So we are going to draw the events at the end of the activity. So next we'll go on to the next activity, which would be activity E, and we can clearly see we have activity B as the predecessor for activity E. So we'll have activity B as the predecessor and the duration is 5. And next we have for activity F, activity C is the predecessor. So we have activity F and the duration is 3 units. And we have the very last activity, which is activity G, which is having the predecessor as activity D, E and F. So you can clearly see in the network I have already joined the activity D E and F. So through this I'll be drawing an activity G, which is having 2 units as the duration. Once the activity G is been drawn, I'm going to close the event. So this would be my AOA network diagram for the given activity predecessor and duration relationship. Once it is drawn, next we are going to number the events. So first event will be numbered 1, next we have 2. Now for activity B and activity C, they both are concurrent. So we can number as 3 and 4, or you can interchange the event number here since they are concurrent in nature. So next we'll have event number 5, and at last it will be event number 6. So if you want to know or understand more about this, how to draw the AOA network diagram and number the events, I'll be putting up the link in the video. You can kindly do check that and understand how exactly we have to draw the network diagram. Right? So now, done with the network diagram, the next step is to identify the different paths of project completion. So we have seen that the path should start from the first event and should end at the last event. So here the last event would be event number 6. So this would be the very first path connecting event number 1, 2, 3, 5 and 6. So we have the path 1, which I'm going to mark it over here. We have activity A, activity B, activity E and activity G. So this would be the first path of our project completion. So we have this as the second path connecting event number 1, 2, 5 and 6. So path 2 are activity A, activity D and activity G. Right? My path number 2. So we do also have one more path, which would be path 3 connecting from event 1 to event 6 along with event 2, 4 and 5. So path 3 would be connecting activity A, activity C, activity F and activity G. So these are the 3 different paths through which we can split it from this network diagram. So once we have these paths, next step is to determine the total duration of each of these individual paths. So how do we determine the total duration of each path? As mentioned, we are supposed to add the duration which we have written at the bottom of each of the activities. We just have to sum it up, right? So we have 1 plus 6 plus 5 plus 2, which would lead to 14 units. So this is the total duration of the first path. So next we'll consider the second path and determine what would be the total duration of this path. So it would be 1 plus 2 plus 2. It would be 1 plus 2 plus 2, which leads to 5 units. Similarly, we'll look into the third path and determine the total duration. It would be 1 plus 4 plus 3 plus 2, which leads to 10 units. Right? So this is how we are going to determine the total duration of each of these individual paths that we have identified. So now, by looking into the total duration, the path having the maximum duration is the total duration of the project. So we can clearly see that the first path constituting of activities A, B, E and G is going to constitute to 14 units, right? So 14 units is the total duration of the project. And coming to the critical path, the path corresponding to the maximum duration of the project, right? The path corresponding to the maximum duration of the project, we call it as the critical path. So the critical path is from event number 1 to 2, 2 to 3, 3 to 5, 5 to 6. So this would be the critical path of the given project, and the total duration is 14 units. So in this way we can determine the total duration of the project and also the critical path. Now you might be wondering what happens if there is a dummy activity present in that given network diagram. Whether do we have to consider the dummy activity or not? So we'll take up this example and see what happens if there is a dummy activity in a project, whether we have to consider that or not. So this would be the question. We have totally 5 activities A to E, and we have the predecessor and the duration of these activities. So if you have any confusions in how to draw a network diagram with dummy activities, I'll be putting up a link over in the video. You can kindly do check on how to draw a network diagram using dummy activities, right? So now always start with the first event, and we can clearly see we have two activities, activity A and B, which do not have any predecessor. So those two are our first event. So we have activity A, which is of 3 units, and we have activity B, which is of 6 units. So once the activities have been drawn, we are going to close it using the events, right? So next we can clearly see we have activity C having predecessor as activity B. So activity C, which is consuming 4 units. So once it is done, we are going to close it using an event. Now in order to draw activity E, we have activity B as well as activity A as a predecessor, right? So we have activity A and activity B as a predecessor for activity D. So now we cannot directly join activity B to activity A because it is going to violate the grammatical purpose of drawing the network diagram, right? So therefore we are going to introduce a dummy. Now at the event next to activity A, we have the relationship of activity A and activity B. Now what I'm going to do, I'm going to draw activity D, which is constituting 5 units. And then we have the very last activity, activity E, which is having activity C and D as the predecessor. So I have activity E, which is consuming 1 units, and then we have the last event. So as mentioned, if you have any doubt in how to draw the network diagram using the dummy, kindly do check up my other video, right, on how to draw the network diagram using dummy activities, right? Now we will number the events. We have event number 1, this would be event number 2, event number 3, 4 and 5. Now we will identify the different paths of project completion. So this would be our first path, connecting event 1, 3, 4 and 5. So we have with activity A, activity D and activity E. So this is our first path. Now we'll look into the second path of project completion. So it would be from event 1, 2, 4 and 5. So this would be our path 2. We have activity B, activity C and activity E. Look into the another path of project completion. So that would be the path connecting event 1, 2, 3, 4, 5. We have path 3 with activity B, with a dummy activity in between, activity D and activity E. Please note that the duration of the dummy activity, which is represented by a dotted line, will be always 0. So that is the definition of dummy activity, an activity which neither consumes any time or any resource. Now, as we have determined the various paths in the network, now we'll calculate the total completion time of each of these paths. So this is our first path connecting activity A, D and E. So now the total duration of the project would be adding up all the activity durations. So that would be 3 plus 5 plus 1, which would give us 9 units. Similarly, for the path number 2, we'll calculate the total duration, which would be adding up the activity durations, which would be 6 plus 4 plus 1, which would give us 11 units. Similarly, for the third path, the total duration of the path would be 6 plus 0 plus 5 plus 1, which would be 12 units. So now in order to determine the total duration of the project, it would be the path which is going to have the maximum duration. So that would be 12 units for the path number 3. So the total duration of the project would be 12 units, and the path corresponding to the total or the maximum duration would be the critical path, which would be the path connecting event 1, 2, 3, 4 and 5, which has activity B, a dummy activity, activity D and activity E. So in this way we can determine the total duration of the project as well as the critical path. Please keep it in mind that this method can only be used when we have a very simple project with least number of activities, because as the project gets more and more complicated, the number of paths of project completion would increase and it becomes very difficult to keep a track on each of these activities and identify the paths. Therefore, this method is only suitable for very small project. So in the next video, we'll be looking into one more method for determining the total duration of the project and the critical path, and that method you can use it for a medium to large scale projects.